Hey, welcome back to my YouTube channel. I'm Xavier Smith, and today I'm going to talk about the 6 types of chemical reactions in chemistry. So let's get started and try to fly through this. First is combination and synthesis. This is a simple one. Synthesis means like the putting together of two things. So our formula for this is A plus B, like yields AB. And A and B could both be like compounds in themselves. It could be like sodium hydroxide could be A and B could be like something else. But we're just doing simple ones that don't have like compounds in them. So N plus Cl yields NaCl, right? Simple. Sodium plus chlorine equals sodium chloride or salt. H2 plus O2 yields H2O. Now we need to do some balancing here. There's 2 oxygens over here, so there needs to be a 2 here. Now there's 4 hydrogens over here, there's 2 here, so we need a 2. So that's combination and synthesis. When you're taking 2 parts and you're making them into 1. The opposite of that would be like, we're getting into it later. Okay, combustion. Basically, this means a carbon compound just and oxygen yields carbon dioxide and water. So this is like carbon compound being burned because you need oxygen for something to burn. Will just give you carbon dioxide. Of course, you're like, oh, burning the stuff, carbon dioxide going away. And then there's water left over at the end. So our example will be C6H14 plus O2 yields carbon dioxide and water. If you ever see a carbon compound and oxygen, it'll likely yield carbon dioxide and water. So if you ever get an equation where it's just like, oh, find the other side, but it doesn't give you carbon dioxide and water, you could probably just guess. Okay, there's 6 carbons over here. There's 1 over here, so we need a 6. There are 14 hydrogens, 14 hydrogens, 2 hydrogens, so we need a 7 here. Then we see there are 12 oxygens, 12 oxygens plus 7 oxygens is 19 oxygens. Well, we can't get that on this side with an even, so we put a 2 here and just double everything. So that 6 becomes a 12. That becomes a 14. And then we see, okay, we have 24 plus 14 is 38. And this will be a 19, because 19 times 2 is 38. So 12 carbons, 28 hydrogens, 24 plus 14 is 38, 38 right here. Now, single replacement. All this means is one thing changes. So you could have A plus BX yields B plus AX, or you could have X plus BY yields Y plus BX. And what the A here is a metal. Well, like the uppercase letter, the A and B are metals, and X and Y, the lowercase, are nonmetals because we see like BX, the metal non-metal pair. So like AX, metal non-metal pair. So we can say like the X and Y are nonmetals. So it's either you could just switch these things, like the A just takes the spot of the B and the B is kicked out and like left to go where the A is, or the X takes the spot of the Y and the Y is just kicked out and then the Y is just like left on the end. Okay, so if we had Zn, like zinc, plus 2HCl yielding ZnCl2 plus H2, first thing you may notice is, well, are they balanced? They are balanced, but you might just see, okay, why is there a just Cl subscript 1 here and a Cl2 over here? Like, what's the point of that? Well, what we're going to get into is the zinc will have a charge of 2, so you'll need 2 chlorines to make up for that charge. And then this H2, you're like, oh, there's a subscript H there. Shouldn't I just leave it plus H at the end? Well, remember our Hibberfonkel, meaning like those are all the diatomic ions. You'll have H2 at the end because hydrogen's a diatomic ion, so whenever it's left by itself, it's H2. Okay, Cl2 plus Ki yields KCl plus I2. Clearly, we have to do some balancing here. There's 1K, 2Cl, because it's in Hibberfonkel, 1Cl, so that will be a 2. And then since we have 2Ks now, we have to go here Now there's two I's, two I's. So we are good. This was switching like the non-metal, it looks like. No, that was switching the metal. This was switching the non-metal. Sorry. Okay, now double replacement, also called metathesis, not metathesis. Okay, so ax plus by yields ay plus bx. You're saying, okay, we could switch a and b and then kick that out, or you could switch x and y and kick it out. Whatever you like more. If you like switching the metals, switching the non-metals, it'll give you the same thing. Okay, so BaCl plus H2SO4 yields BaSO4 plus HCl. You can see that the Ba, well, I'd like to say the Ba and H switched, but really it looks like the SO4, the sulfate, and the chlorine switched. Okay, so we have two chlorines on this side, one chlorine on this side. We need a 2. Then we have one barium on this side, one barium on this side. We're good. 2H on this side, 2H, 1SO4, 1OSO4. SO4. So you could change two metals or you could change two non-metals. An important thing is metals can be like interchanged and switched with metals, and non-metals can be switched with non-metals. Don't be switching metals and non-metals. Like a metal switching with a non-metal, don't do that. It won't work out as well as you think. Okay, decomposition. There are 4 types we're going over. There's going to be our binary, which is AB yields A plus B, which is our H2O example. H2O yields H2 plus O2. Well, clearly there's 2 O's over here, 1 over here. We're going to have to balance that, put a 2 there. Now there's 4 H's, 2 H's, need a 2. So that's just going from, okay, here's something. Here's like our calcium hydroxide, right? And then we're just going to split it up into Ca plus OH2. All right. Now our metal carbonates and our base like formula is going to be MCO3. So that'll be metal carbonate yields MO plus CO2. So you're going to have a metal oxide plus carbon dioxide. Okay, so our examples, Na2CO3 yields Na2O plus CO2. You can see Na is our metal, and then we yield CO2. So we have like sodium oxide. So you're going to have metal oxide and then CO2. So if you ever see like a metal carbonate, you can guess what it's going to yield. A metal oxide, that metal oxide, plus CO2. And I believe that's already balanced. Metal hydroxides, we're going to have metal hydroxide, of course, yielding metal oxide plus H2O. So our example is calcium hydroxide yielding CaO plus H2O. So here, calcium is our metal, and then we have calcium oxide plus water. So this time, you're yielding a metal oxide and H2O. So these two are pretty similar, metal carbonates and metal hydroxides, because you yield a metal oxide and then basically just you're left with something. So you're left with like, you have MCO3. If you take a metal oxide out of that, you're left with CO2. You can remember that. If you take out MO from like hydroxide, it might not be as simple, but it should work. Okay. Now, calcium hydroxide yields CaO plus H2O. Of course, that 2 is in the wrong spot. Sorry about that. Okay, so there's 2 H's, 2 H's, 2 O's, 2 O's, Ca, Ca. And clearly you can see the charges change. You're like, oh, but there's 2 oxygens on this side. There's 1 oxygen over here. Well, it's because calcium's a charge of 2 plus and oxygen's a charge of 2 minus. That's just how it's going to go. You're going to see when you're changing sides, the subscripts are going to change due to charges. You're going to be recombining them. Metal chlorates. All right, now we're going to finish off with the metal chlorates, which is MClO3 yields MCl plus O2. Examples, KClO3 yields KCl plus O2. Balance 3, 2, 2, 2K, 2K, 2CO, 2CO, 6O, 6O. Last one, which we're not going to be using until like later on in honors chem, is acid-base reaction. You're going to have an acid plus a base yielding H2O and salt, so water and salt. So HCl plus NaOH yields salt and water. You're just going to do that over and over. Okay, thanks for watching.